Alright, in this video we're going to be doing a type of transformation called a dilation, and basically all a dilation does is it changes the size of the original shape. So we can make an enlargement of the original shape, or we could take the original shape and shrink it down into a smaller shape, but basically the proportions are all still going to be the same. So in other words, the shape that we end up with is going to be similar to the original shape. So an example of a dilation might be taking a triangle such as this, and if we dilate it, we could end up with maybe a triangle something like this, similar to the original triangle. Obviously I didn't draw those very carefully, but these will be similar to each other because we're only changing the proportions of the shape. Alright, so a couple of things that come into play here. The first is the scale factor, and that tells us how much bigger the new shape is than the original shape, or in some cases the image or the new shape could be smaller than the original shape. So if the scale factor is greater than 1, what that tells us is that the new shape is bigger than the old shape or the original shape. And if the scale factor is less than 1, then that tells us that the new shape is smaller than the old shape. All right, so the scale factor just tells us how many times do we multiply the original shape by itself to get the new shape. So if we have a scale factor of 2, for example, that tells us that the new shape is twice as big as the original shape. But if, on the other hand, we take a scale factor of, let's say we had k equals 1/3, what this tells us is that the new shape is going to be 1/3 the size of the original shape, or 3 times smaller. So again, if k is greater than 1, that tells us the new shape is bigger than the shape we started with, but if k is less than 1, that tells us that the new shape is smaller. So again, anytime you see a fraction like this where your numerator is smaller than your denominator, that tells us that our k is less than 1, and it tells us that the new shape is going to be smaller than the original shape, or the image is smaller than the original. Okay, so the scale factor is very important here. It tells us the relationship between the sizes of our two shapes. So as a rule, how we can do this, and this is a very specific example here that we're going to do. There are multiple ways to do dilations, but in this video we're going to be looking specifically at dilations where the center of the dilation is 0, 0, or the origin. All right, so if this is the case, all you have to do to get the new coordinates is to take the coordinates that you had and multiply them by the scale factor. So if we had a shape that had a coordinate of, let's say, 1, 4, and we had a scale factor of 3, then to get our new coordinates, all we would have to do is multiply the original coordinates by the scale factor. So in this case, our new coordinates would come out to be 3, 12. All right, so if you're doing the origin as the center of dilation, this is all you have to do, is multiply the original coordinates by the scale factor, and that will give you the new coordinates, and then you can plot them from there. But if the origin is not the center of the dilation, there's going to be a slightly different process that we'll go over in another video. So let's try out a couple of examples here. Hopefully you're getting the hang of what a dilation might look like. So if we take an original shape, let's say we have a triangle like so. So we have 3 points here. We could label this triangle ABC. So the first thing is we want to figure out what are the coordinates of our original shape, right? So we have point A here, which is at 1, 3. We have point B, which is at 4, 3. And we have point C, which is at 1, 1. So let's say we wanted to take triangle ABC and we wanted to dilate it with a scale factor of 2. So all we're going to do here is multiply each of these coordinates by the scale factor, which in this case is 2. So if we take our point A and we multiply the coordinates by 2, that would give us a point 2, 6. If we take point B, that would give us a point of 8, 6. And point C, that would be a point 2, 2. All right, so if we want to find our new image shape and where that's going to be located on the coordinate plane, we now have the coordinates to do so, and we just have to plot these points and connect the dots to make our new shape. So if we go ahead and plot these points, we have 2, 6 for our new point A, we could call it A prime. We have 8, 6 for our new point B, so we could call that B prime. And we have 2, 2 for our new point C, so we could call this C prime, even though it's kind of in the way of our original shape there. All right, so we could then connect the dots, and that would make us our new image of triangle ABC, or we could call this one A prime, B prime, C prime. All right, so if we look at this, we have the same shape that we started with. It's just bigger, or in some cases it could be smaller, but in this case it ended up bigger. So it's the same shape. It's similar because the proportions of the sides are all the same, and the only difference is the size of the shapes. The orientation stays the same, the angles stay the same. The only thing that changes is the proportion of the sides in these triangles when we compare the image to the original. Okay, so this is an example of a dilation where k was greater than 1, right? Because we had k equals 2, obviously that's greater than 1. That means that we're getting a bigger image or a bigger new shape than the original shape that we started with. All right, so let's try an example now of a dilation where we might be getting a smaller point than we start, or shape than we start with. All right, so if we plot another triangle here, we could maybe do something like this. Okay, so if we take this and make it triangle, let's call it CDE in this case. So if we wanted to dilate this, let's say with a scale factor of 1/2. How we could do this is take our original points and multiply them by the scale factor, and then we'll get our new points. The process is the same. The only difference is our scale factor is less than 1, so we can already imagine our shape needs to be, our image shape, our new shape needs to be smaller than the original. All right, so if we go ahead and dilate point or triangle CDE, we first need to have the coordinates for each of these points. So C is at 4, 4, D is at 4, 8, and E is at 8, 4. Okay, so when we go to dilate these, we have to take our points and then multiply them by the scale factor. So we're going to apply the scale factor of 1/2 to each of the points in this shape. So if we multiply the coordinates 4, 8 by 1/2, that would give us 2, 4 as the new coordinates. 4, 4, we would have 2, 2 as the new coordinates, and 8, 4, we would have 4, 2 as the new coordinates. All right, so when we go to plot this triangle, we could plot point 2, 2, and that's our new point C, call it C prime. We have 4, 2, which is our new point E, call it E prime, and then we have 2, 4, which is our new point D, we could call that D prime. So if we connect our dots, we can make a triangle there, and we see, again, we have the same exact type of shape that we did when we started with. The only difference is that it's smaller than the original shape. So we have, again, a similar triangle because all the sides decreased in the same proportion relative to the original shape. All right, so this is another example of how we can do a dilation. In this case, because we had a scale factor that was less than 1, that means that our shape is going to be smaller than the original. All right, so if you want to try out, I'll throw an example out here for you to try out on your own. Let's maybe work our way into a different quadrant here. Let's say we have a triangle like so, and let's say we were going to dilate this triangle with a scale factor of, let's say, 3. Okay, so if you want to try this one out on your own, I can give you the coordinates here in case you can't see it too well. So the coordinates, if we make this triangle, let's call it x, y, z. The coordinates here would be x is -3, -1, y is -1, -1, and z is -2, -2. All right, so if you go ahead and dilate this triangle with a scale factor of 3, you can go ahead and try this on your own, see what you come up with, and then come back to see the solution. All right, so if we go ahead and dilate this triangle, what we have is a scale factor of 3. We want to apply that by multiplying it to each of these coordinates here. So we're going to take 3 and multiply it by each of these. So this would give us -9, -3. This would give us here -3, -3, and then this would give us here -6, -6. So again, all we did was multiply the scale factor by each of the coordinates, and then that gave us our new points for the image shape or the new shape. So we can go ahead and plot these new points that we have now. We have -3, -3. We have -9, -3. And we have -6, -6. So we can connect our dots here. All right, so we have our new point x, x prime, y prime, and z prime. All right, so again, we can see the shape looks exactly like the original. The only thing we've done is change its size. So again, these triangles are going to be similar, and the orientation is the same, right? Point x is still to the left of point y. Z is still below x and y, right? So the orientation, everything stayed the same except for the size of the shape and the location where it was on the coordinate plane. All right, thanks for watching this video on dilations, and I'll see you in the next one.